B is -1 and C is
Okay,
-2.
good. Okay. Um, so quadratic formula, you may have to memorize this. How are you at memorizing stuff?
Um, about average.
Okay. I mean, I'm going to write it down each time, but I already know it, so it doesn't do me any good to keep writing it down. You would be wise to write it down every single time we do a problem here.
Oh,
Okay.
we're about to enter because I'm in the car on my phone right now, but
Okay.
we're gonna enter a dead zone in my neighborhood, so I might lose connection. So
How much time do you need to get back to where you're kind of ready to go?
maybe 2 3 minutes. That's
Okay.
out. That's if it disconnects.
Okay.
All right, so
This part's pretty important is that the variables, the letters are actually they're actually really in parentheses, just the letters. The reason this is important is most of the mistakes are made substituting in for the numbers. So when we do that here next, hopefully you're still with me. Actually, let me grab these. I need to, don't have enough room on the screen. So this looks like this: -1 plus or minus the square root -1 squared minus 4 times 1 times -2 all over 2 times 1. Let me know if you're still there.
yeah, I'm still here.
Okay. The part under the root is the most, that's the place where you're going to see most of the errors. So that's, and I don't know if you're in a place where you can work that out in your notebook there. Is that possible? But just the part under the root, like just this part in the square root here, not all the rest of it, just that part.
So 1 plus or minus, oh,
Just the part
negative
under the
two
root.
minus under the, okay.
Okay, so like
So
this
2.
no, this part under the root here. This is where most of the mistakes are made. That's why I want us to focus there first. -1 squared is -1 times itself, -1 times -1.
Okay. Minus 1. Hello?
Yep. Let me know when you get your final answer for all this.
Oh, okay. I'm just gonna head inside and
Okay, yeah, that's fine. Just let me know when you got
my
it. You can use
laptop.
that.
I should be back in a minute.
Sounds good.
Okay, I'm back.
Okay, how are you doing on that calculation there?
No, let me see. Negative. I got -2 plus 8.
So -1 squared is +1.
Yeah.
That's
Hold on.
-1 times -1.
Oh, I think of this. I was okay. Sorry. I was
And
doing the
then,
thing under the square root.
yeah, just the part under the square root. This 4 times 1 times -2 is what?
Should be that's -4 over times -2 should be +8.
Okay, so it becomes +8, and that's 9. So the part under the root, and that's really where you want to start this calculation. It's 1 plus or minus the square root of 9 over 2. Okay, this is where you're getting to.
Okay.
All right, now very important here is that um, you know how to evaluate this. It's actually in parentheses in the top. So you do the top first.
I'm just gonna join on my laptop real quick. I'm gonna.
Okay, sounds good.
All right. Okay, I'm on my laptop now.
Okay, yeah. So what I was trying to show you here is that this is it's really two different problems. It's 1 plus the square root of 9 over 2, 1 minus the square root of 9 over 2. But you have to evaluate the top and the bottom. You have to evaluate the top first, then divide. So could you simplify this for us, please?
Okay. I got for the one on top, I got 2, and the one on the bottom, I got 1.
Yeah. Well, should be -1 on the bottom. 1 minus 3 is -2. Um, but is that the same as what we had before? Yes.
Yeah.
Okay. So let's we got kind of interrupted there, but let's try another one here. Let's say x squared minus 3x plus 2 equals 0 here. Do you have any idea, remember how to factor this?
Uh, oh, my notebook's in there. That's not good.
So you're looking for two numbers. They have to multiply to 2, positive 2, but then they have to add to -3. Multiply to 2, but add to -3.
Okay.
Any idea what those could be?
-2. So should it be x minus 2?
Yep, that's one of them. And then X.
X plus 3. No, minus 3 or 1.
They,
Yeah.
uh, so the reason it's one is those multiply to 2. I don't know why students don't focus on that one first. Like generally it's like that's the one to focus on. Because there's actually an infinite number of numbers that add to -3, but only a finite number of numbers that add to 2. So we know that we know our answer here, and we know our answer is 0. I'm sorry, x minus 2 equals 0, x is 2, x is 1. So we know our two solutions. Okay.
Mhm.
All right, now let's do the whole quadratic thing. X squared minus 3x plus 2. What's the value of A, B, and C?
A is 1, B is -3, and then C is +2.
Good. Now we're going to do just the part under the root first. B squared minus 4AC. And
Mhm.
again, like you want to treat the variables as if they're in parentheses. That will definitely help you here. Could you calculate this for us, please?
Okay. I got -17.
Okay, so it's parentheses -3 squared minus 4 times 1 times 2. Is that what you have?
Yeah,
Okay, what is -3 squared? -3 times -3.
is -9.
No,
Oh,
-3 times -3 is +9. The two negatives become positive.
yeah,
Okay. All right. So that's 9 minus what's the next one here?
it's 4 times 2, which is 8.
Okay, so what does that reduce to?
1.
1. Okay. So now if we go back, like this is the part under the root. So our quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we know that b is -3. So it becomes -3 plus or minus the square root of 1 over 2 times 1. So you already did that part, the b squared minus 4ac, that's 1. And I was just filling in the rest. Is that okay?
Yes, okay.
All right. So now in the numerator becomes 3 plus or minus the square root of 1 over 2. Could you simplify those for us, please?
I got 2 or 1.
That's what we expected. Okay. Now, we'll look at another problem here, but there are only certain numbers that you know how to take the square root of. So can you give me the result of simplifying these square roots?
So 0, 1, 2, 3, 4.
Good. And this list goes on for a while, but you can see that there's actually more numbers that you can't take the square root of. Like what is the square root of 3, or what's the square root of 11? And and these are typically considered like unfriendly, but they are still answers. They're just not what you want them to be. Okay. And that's probably the direction you guys have been trending towards in class. Um, does that look
Yeah,
familiar to you?
yeah.
Okay, okay. So we're gonna trend towards some problems now, like you guys are doing in class. If I can find any. Of course, this one doesn't
Okay.
have any on the first worksheet I go to. All right. Grab another one here. All right, let's look at number. All right, so here's one for us to try. You know, it doesn't look too bad at first glance here. X squared minus X minus 3. This one does not factor. A is 1, B is -1, C is -3. Always a good idea to write the quadratic formula a few times here. All right, so I want you to calculate the part under the root here,
Okay.
please.
Okay.
Let me know when you got an answer, please.
All right.
That's -3. That's not written well. That's a -3.
Could it be 14?
It is not 14. We give that one more look.
1, 2. Minus.
This is one of those places where if you're allowed to use a calculator, I mean,
Oh,
I don't have a problem with using one. Yeah, I'm not anti-calculator.
let's see. Oh, wait. Okay. Oh, that one is -1. -1.
So this first part, -1 times -1 is 1. And
Yeah.
then you might look at the signs here. See how they're both negatives. That tells you it's a plus. 4 times 1 times 3 is 12. And like I said, if you're allowed to just calculate, you just put this right in. Let it give you the result here.
Yeah.
You can see, going back to the quadratic formula here in the top right, it's now 1 plus or minus the square root of 13 over 2. And this is where you're sort of stuck. There's nothing more to do here.
Yeah.
So this part under the root is key. That's really the most important thing for you to be able to do. So that's what we're going to keep working on. Any questions, thoughts on that before we proceed?
No.
Okay. It's a little monotonous. It's a little like, we got to do this again. It's like, yeah, we got to do it again. I don't make the rules. So, um, let's try, let's see if I've found another one here. This one looked okay. All right. So, yeah, I was trying to avoid that. Let me
But
grab
what?
another one. They're kind of like the way I teach you through these lessons, I try to incrementally uh, create the problems rather than put a bunch of new stuff in front of you, which is what most teachers do. They don't realize that, uh, like it hurts learning if you've got a bunch of these like non-sequential problems there. Let me look at this one. So, just let me grab one more worksheet here, see if I can find one that's got what I want. Okay, none of these are working out the way I want. So let's try something different. You can't see on either screen here. I'm frantically trying to find more problem, but all right. So here's one for us to look at next. 2x squared plus 12x plus 5 equals 0. Can you give me the values of A, B, and C in this problem?
A is 2, B is 12, and C is 5.
All right. So our quadratic formula, opposite of B, plus or minus the square root of B squared minus 4 times A, which is 2 times C, all over 2 times A. All right, so could you simplify the part under the root for us, please?
The like the answer or just like what's
Just the number under the root, just whatever that is, 12 squared minus 4 times 2 times
I got
5.
104.
Okay, good. Now, this is new, and this is where I was trying to hold off on showing you this. Did you guys talk about how to reduce roots in the classroom?
Uh, let me s- uh,
Because that's sort of its own
divide.
lesson.
I I see something like what you just wrote on my notes. So I think yeah.
So let me show you how to reduce this root. You start with 2. 2 times 52 is 104. And then you try 2 again. 2 times 26 is 52. This, because there's a pair of 2's,
Yeah.
the 2 comes out. So this becomes, the square root of 104 becomes 2 square root of 26. So again, ask kind of the same question. Did you see something like that in class?
Nope.
Okay. All right. That's frustrating. Let's go back to working on some quadratic formula problems that work out nicely rather than kind of the ones that I've been sort of focusing on with these roots. Right, so here is a new one to try. This one does not have some of the issues that we've been working on. So here A is 2, B is -3, and C is -5. All right, so let me write the quadratic formula here. Minus B plus or minus the square root B squared minus 4AC all over 2A. Again, it's probably a good idea to put the letters in parentheses.
Hmm.
You won't see this taught this way, but it really is a pretty effective strategy. And
Hmm.
then I'd like you to simplify under the root.
Okay. -49.
It is not negative. Um, or is it?
Oh,
No. Sorry, this is C is -5. I didn't put that in there.
oh.
That will slightly change your answer.
So it's +49.
Yes, yes. So it's 3 plus or minus the square root of 49 over 4. Could you simplify those for us, please?
Uh, I got 2.5 or 1.
So one of those is correct. So it should be 3 plus 7 divided by 4, and then 3 minus 7 divided by 4. So double check those calculations. Remember, you're doing the numerator first. Wait, did you say -1?
Yeah,
Said
wait.
okay, you're correct. I'm sorry. I was looking at I was looking at a different problem. I was looking at the next one we're doing. I'm like, oh, okay. All right, good job. Now, sometimes the problems already have A's and B's in them. And sometimes they're not set equal to 0. Like if you look at all the problems we did today so far, equal 0, equal 0, equal 0, so on. You have to first get it set equal to 0. So how do you move this forward to the other side of the equation?
Do you divide? Wait, no, you don't divide. You
It's
plug
just
in
hang it out over here. It's positive. How do you undo a positive?
by subtracting by subtraction.
There you go. So this is 4b squared plus 8b plus 3 equals 0. Um, the thing here is that I was going to mention is that like sometimes they're not using X, sometimes it's letter B. You can still, if you don't like it, you can change it to 4x squared plus 8x plus 3 equals 0. Um, but you still have to identify your A, your B, and your C.
Hmm.
So could you attempt to identify A, B, and C for us, please?
A is 4, B is 8, and C is 3.
Okay. So this one, since it's all positives, I'm gonna let you take it from here. Shouldn't be too many issues calculating this.
Okay. For the thing under the square root, I got 16.
That's correct.
So Well, okay. I got x equals -1/2
Okay, anything else?
and x equals -3/2.
Those are both correct. Very good. You did really well on that one. Okay, let's just, I mean, this is likely to come up here. I'd like us to talk a little about how to reduce roots for the rest of the lesson. Are you okay with that, or do you want to do more quadratic formula? You're the customer, so you get to decide.
Let's focus on the roots.
Okay, so I'm going to start with one of the most basic problems we can start with, which is the square root of 12. Okay, which is not a perfect square. Doesn't work out perfectly. You can go to your calculator, but that's not the intent here. You have to start with prime numbers. Do you remember any prime numbers?
Isn't one a prime number?
One is not prime. It's sort of that odd one that you
Oh
would think
no,
would be.
one can't be a prime number. Never mind. Is it 2,
Give me a couple
3,
more. Three, good.
5, 7, 11, 13,
Yeah, good.
17?
That's good. Good. We won't need to go much past five, at least for what we're doing. So you always start with two. Is 12 divisible by two?
But yeah,
Two times what number?
6.
Six. And then you try it again. You're like, does two go into six? Well, it does. Now, this is called a prime factorization. Okay. And you know you're done. A lot of students are like, when am I done? When you have primes on all the leaves, the outer edges there. Now you circle pairs. For each pair, you bring one out. You bring, in this case, a two out. If you don't have a pair, it stays in. So your answer always is a part that's outside and a part that's inside. So in this problem, because you have a pair of twos, you can only effectively bring one out, the two out, and the three stays on the inside.
Mhm.
Okay, let's look at another example here. Square root of 20. Start with two. Does two go into 20?
Yes, by 10.
Okay, and then you try it again. Two times what number
5.
gets you back? Five. They're all prime numbers, so you circle pairs. You bring a two out, but the five stays in because there's nothing to go with it. So your answer is 2 square root 5. So I'd like you to try the square root of 28 here.
All right. So 2 stays out, 7 stays in.
So the way you would write your final answer is you would say 2 square root 7.
You get 2 square root 7.
Good. Okay, now new style of problem here. What if we want to find the square root of 18? Well, you start like we just did. You say, okay, 2 and 9. But 2 does not go into 9. 9 is not prime. So you go to your next prime number. Does 3 go into 9?
Uh, 3 times.
Yeah, and those are both primes. So your pairs, you've got a pair here. So your 3 is coming out, but your 2 is staying in.
Mhm.
So the square root of 18 is 3 square root 2.
Okay.
All right.
Got it.
So square root of 45. Does 2 go into 45?
I don't know.
It's not even, but 3 does. 3 times what?
3 times 15.
Okay. All right. And then
3 and 5.
3 and 5. So tell me the final answer. What goes out? What stays in? Give me your final answer on this.
3 square root 5.
All right, very good. Okay. Um, let's try another one. Square root of 40. Does 2 go into 40? Yes, because
Yeah.
it's even. So 2 times 20, 2 times 10, and 2 times 5. Now, you circle pairs. This time you've got 3 2s, but you can only bring out if there's a pair. It's kind of like socks. I like matching socks. Uh, but there's nothing to match the 2 with. There's nothing to match the 5 with. So the 2 is going to go on the outside. It's the square root of 2 times 5 on the inside. These stay in, but they're multiplied together. So you end up writing 2 square root 10 like that.
Okay.
Does that make sense?
Yeah.
So whether they're on the inside or the outside, you do end up multiplying. All right. I want you to try this one on your own, please. Do the
Okay.
best you can. We'll talk about it if we need to.
Okay. Would it be 3 square root of 3? What did I do
Okay,
wrong?
let's take a look here. So it's 2 and 27,
Yeah.
3 and 9, 3 and 3. So I agree that there's a 3 that comes out, but what stays on the inside?
A 2.
And
A 3.
so they're both there. So what does that become?
Times 6.
Okay. All right. So let's try another. Let me try another one here. Square root of 150.
Okay. I just got a little question. Do you,
Yeah, of
for,
course.
is it 2 or 3 for the first pair?
You always start with 2. Does 2 go into 150?
75.
Yes, and then 2 does not work, but 3 does. It's really, really important that you do it in order.
Yeah.
It really,
So
really is.
that's what, I got that, but I'm wondering how do I write it because there's no pair.
Does 3 go into 25?
No.
Does
5.
5?
Yeah.
Okay, now are there any pairs?
Oh, the 5 on the bottom.
Yes.
That explains a lot. Yeah.
Tell me your final answer here.
So it should be 5 square root 6.
Now you just alluded to something really important here. Let's look at a problem like this one, the square root of 30.
Mhm.
Square root of 30, 2 and 15, 3 and 5. Do you see any pairs?
Not yet.
And they're all primes on the leaves, so you're done. So the
Fine.
square root of 30 is the square root of 30. So
Yeah.
sometimes you get a number that looks like it's, should reduce, but it doesn't.
Yeah.
Okay, another type of problem you'll see, and we'll start with 32, is this becomes 2 and 16, 2 and 8, 2 and 4, 2 and 2. Now you can get multiple pairs. For each pair, you bring one out. So this becomes 2 times 2 square root of what's left over, which is 2, 4 square root of 2. And that's okay. You can absolutely get more than one pair. In fact, you can even get more than one pair, of different numbers. All right, so let's have you try one like that. Go ahead and try reducing this one, please.
Would it be 6 over 1? 6 square root of 1?
Would not be the 6 is correct. It's 2 and 54, 2 and 27, 3 and 9, 3 and 3. So pair of 2s and pair of 3s. So you got that part right, but what's left over?
The other 3 on the bottom.
Yeah. All right. So good job. Hopefully seeing this with me when you see it in the classroom,